ideas. In the previous class we studied ideas. In the previous class we studied about the sample. Now we are going to study about the estimator and estimate. Same thing in the population. Suppose we are studying about some population, right? You want to find the mean of the population. Okay, which is denoted by mu. So we are not going to, it is difficult, as I told you before, difficult to study about the population, right? So we have to study about some sample we have to take, right? This is the sample and this is our population, which is a universal set. Suppose you are going to study about the mean of the population mu. So you will be taking sample mean, that is noted by x bar. This is known as the estimate. Okay, mean will have some particular value like 4.5, 2.2, some value it will have. That is known as the estimate. Because we are going to estimate about what? We are going to estimate about the population. Right? So this is known as the all about the estimator. Mu naught is known as the estimator. Sorry. Mu naught is known as the estimator, and the particular value x bar is known as the estimator. The particular value of x bar, it may be 45, 32, 25, something like that. That particular value is known as the estimate. Okay. Now, any statistic, sample, I told you before in the unit 1, it is statistic. Okay, if we talk about mean, median, mode of the sample, it is known as a statistic. And something about the population is known as the parameter. For example, mean of the population, median of the population, standard deviation of the population, all this known as a parameter. Population parameter, sample statistic. Okay, any statistic used to estimate an unknown population parameter, because we are going to estimate about the unknown population parameter, is known as the estimator. Okay, and the particular value, okay, a particular value of that is set of the estimator is known as the estimate of the population, estimate of the parameter, right? The estimated value of the sample and sample variance are denoted by, this is the estimate value of the sample mean. Okay, sample variance is noted by S square, right? So, if a statistic is used to estimate an unknown population parameter, then it is known as the estimator. The value of the estimator based on the observation of the sample is known as the estimate of the parameter. We are going to estimate what? Estimate of the parameter. Right? We are going to find the value of the parameter. Means we are statistically we are doing that. For example, suppose the parameter lambda of the Poisson distribution. We have studied the Poisson distribution. So, a random variable x said to follow Poisson distribution whose parameter is lambda. This is our population. Suppose you want to the parameter lambda of the population, sorry, of the Poisson population. We want to find the parameter lambda of the Poisson population. Our Poisson population is some x comma lambda. We want to find the value of lambda, which is unknown. What is about my lambda? Lambda is unknown. The parameter is unknown, right? We want to estimate about it. So, we draw some sample. From the population, we are going to draw the sample. Let it be x1, x2 and so on to xn. These are the samples. What is the size of the sample? Size of this sample is n. Okay, this is taken from the Poisson. Okay, this Poisson. This is taken from the Poisson population, right? Which we are trying to estimate. So from the Poisson population, we are taking the sample which is of size n. This Poisson population, we want to estimate by this way, we want to estimate the lambda. That is what our aim is, right? So what we find x bar sample mean, we'll find now. What is sample mean? Sample mean equal to, that is x bar, which is equal to summation xi by n. Why we are doing this? To estimate lambda. So we are doing this. Then x bar is called estimator. Okay. And then any particular value of this estimate. Okay. For example, suppose my x bar equal to 35 and this is known as the estimate. Okay. Any particular value of this, which is known as the estimate. So consider another example now. For another example, what you are going to see is, if you want to estimate the average height mu of students in a college. So I can take CUTN, right? Our CUTN, I want to find average height. Average height of students. Our CUTN becomes our population now. Okay, all the students of CUTN becomes our population. So what you want to estimate? Average height of the student. That is my mu. This is what we want to find, parameter. We want to find population parameter. Sorry, I used the word estimate. I'm so sorry. This population parameter. Right? So what you will do is, sample. We take some sample from this. Okay, sample mean we'll find. I'm telling again and again, sample is selected scientifically using the sampling, right? Just like that you cannot select the sample. Okay, it should be scientifically selected using all the statistics methods. So I am taking a sample, I am finding the sample mean x bar. Then x bar is nothing but our estimator. What is my x bar? Estimated. Its value is known as the estimate. X bar will have some value, no? That is known as the estimate, right? Particular value, okay? For example, it is 165 centimeter. Suppose I am getting x bar equal to 168, I can take. 168 centimeter. That is nothing but estimate of my population parameter. What is my population parameter? Average height of the students, right? Now we'll go to the next topic. Law of large numbers. Very important topic it is. What is the topic is about? Law of large numbers. Right? What is this all about? This law states that for any two arbitrary small number, take any two arbitrary small number, epsilon and neta. This tells something about your real analysis, right? For any arbitrary small numbers, epsilon and neta, where epsilon is greater than 0 and 0 lesser than neta lesser than 1. There exists an integer there exists an integer n such that if a random sample, this is much similar to your real analysis only, okay? So there exists an integer n such that if a random sample of size n or large, okay, is drawn from the population and calculate this calculate. Okay, and what you are going to do, calculate the sample mean x bar for this sample. Okay, then the probability that x bar deviates from mu. See, again and again I am telling same thing. You are going to estimate about the population parameter. Means not exact number, it will be very closer to population parameter, and it's not it may not be equal to population parameter, because we are going to estimate only. Maybe it is closer to population parameter. So you are going to take one sample whose size is n, and you are going to calculate from the sample. We are going to find the sample mean. That is what we have seen. Okay, this size n, I am talking about the size of the sample n. That is what now we are bothered about, right? Up to this I hope you understood. Okay, so then the probability of x bar deviates from mu, okay, by less than epsilon is greater than 1 minus eta, means as close to 1 as desired. Okay, that is x bar arbitrary close to mu. Means what you are going to see is very simple. What you are going to do is, from this you are going to population, you have to take a sample, right? From population we are going to select a sample. Okay, what is the size of the sample we have taken? Size is n. This n only we are bothered. Now we are talking about this n only, right? That is what our main concern is all about. So the sample size is n. Okay, from the population we have taken a sample whose size is n, and then we have now selected epsilon and eta. Forget about it. At present you forget about it. Okay, then we want to here we want to find the mu parameter mu. That is what parameter we are considered here is mean. Okay, we want to find the value of this mean. From the sample we will find some x bar, right? And this x bar, how much it is closer to mu, right? That is a question mark. Means how much it is closer to the mu. It should be as close as possible, right? Very close to 0. That is what exactly we are expecting. That is how much it now it will deviate. For sure it will deviate, right? X bar deviates from mu by less than epsilon. Okay, less than epsilon means what? Epsilon less than epsilon means epsilon is a number very close to 0. Okay, that means this mu is very close to, sorry, this x bar is very close to mu. If epsilon, this difference between mu and epsilon, sorry, difference between mu and x bar, I'm so sorry, difference between mu and x bar, their difference, it is lesser than epsilon. That means epsilon is a number lesser than 0, means this x bar is very close to mu. X bar is very close to mu, right? That is what we want to say, right? Understood, right? So this is what we want to, we are exactly bothered about what is the size of n, so that my x bar, that is what my statistics is what? Sample statistic. That is my x bar, that is mean of the sample, should be closer to our population mean, and from that is